Hello viewers, I am Kausalya. Today we are going to solve problems in exercise 12.3. Problem 1. Find the area of the shadowed region in figure if PQ is equal to 24 cm, PR is equal to 7 cm and O is the center of the circle. So here this is our diagram. Right. So in this diagram we are having a triangle and a circle. And the sides of the triangle are given, right? PQ is 24 and PR is 7, right? And O is the center of the circle here. So here we have to find the area of the shadowed region, right? So this is our shadowed region, so we have to find this area. So when you look at this circle carefully, you see this is a right angled triangle, right? Why this is a right angled triangle? Because here we are having a perfect 90 degree. There is a perfect L shape, right? So I know two sides of the triangle. Now I am going to find the third side by using Pythagoras theorem, right? So what is Pythagoras theorem here? You see RQ square is equal to RP square plus PQ square, right? PQ or QP. Just substitute the values. So here I am getting the value as 625. That is RQ square is 625. Therefore RQ is 25 centimeter. Right. Now you see we have calculated the value of RQ. Right. So how to calculate the radius of the given circle? For this given circle, you see this is a diameter, right? So when you divide it by 2, then we will be getting our radius, right? Therefore, here the radius of the circle will be 25 by 2, right? So, again you see, here when you observe closely, you see this is a semicircle. Say yes or no? Yes, right? So, this is a semicircle and here we are having a triangle. When you find the area of the semicircle and you subtract the area of the triangle, then we will be getting the area of the shadowed portion. Right. So as a first thing, you see, just write down the statement. Area of the shadowed region is area of the semicircle minus area of the triangle. So what is the formula? Area of the semicircle is pi r square by 2. And area of the triangle is of BH. Right. So here what about the radius? Here this is our diameter, right? So radius is obviously, so you see diameter is 25. Here diameter is nothing but our RQ. Therefore OQ is equal to OR, which is equal to radius, which is equal to 25 by 2. Right. So the value of R is 25 by 2. So just substitute the value here. Right. R square is, that is R is 25 by 2. So R square, here we are having two terms. Minus half B into H. So when you look at this triangle, you see this is B and this is H. Right. So 7 into 24. 1 by 2 into 7 into 24. So as here you see 2 and 24, they cancel each other. And again I am moving this 2, right, to the numerator side. So here it is 2 by 1. When you shift this 2 by 1 to the numerator, it becomes 1 by 2. And again this 2 and 22 cancels each other. So here the remaining terms are, you see 11 into 25 square is 625 and divided by 7 into 4, right, minus 84. So when you multiply here, you are getting 11 into 625 is 6875 by 28 minus 84. And the next step is we have to take LCM. Right. So how to take LCM? Here it is 1. So I am multiplying both the numerator and denominator by 28. So 84 times 28 is 2352. And when you solve, we are ending up with the answer as 4523 divided by 28 centimeter square, because here this is area of the shadowed region. Okay, whenever you come across area, unit should be in square. Right. So now we are going to solve problem number 2. So in the problem number 2, you see, find the area of the shadowed region in figure if the radii of the two concentric circles with center O are 7 cm and 14 cm respectively, and angle AOC is 40 degree, right? So here we are having two concentric circles, right? So here we are having two circles, and the radius of one circle is 7 and the radius of the other circle is 14, right? So here we can write it as, what is the radius of the inner circle? It is OB or OD, right? Here OB and OD both are radius. So it is equal to 7 and OA is equal to OC, which is equal to 14, right? So again the angle subtended by the two lines are also given. It is 40 degree. So here we have to find this area, right? So how to calculate this area? Again, when you look at the diagram, you see this part is a sector, right? BOD is a sector. Yes, right? Because we have two radii and a corresponding arc. Similarly, this AOC is also a sector, right? Because OA and OC are the radius. So AOC is a sector again. So how to find the area? You just calculate the area of this bigger sector, right? And then subtract the area of this smaller sector. Then obviously we will be getting the area of this shaded region, right? So just write down the statement. Area of the shaded region is area of the sector OAC minus area of the sector OBD, right? So what is the formula? To calculate the sector, it is theta by 360 into pi. Here I am assuming, okay, here even we can write a statement, let R2 is equal to 14 and R1 is equal to 7 centimeter, right? So pi R2 square minus pi R1 square. So here again when you substitute the value of theta and R, you see theta is 40, right? So 40 by 360 into pi into R is 14, and here 40 by 360 into pi into here R is 7, right? So when you consider these two terms, you see 40 by 360 and pi are common. So we can take these terms outside, right? So when you take this term outside, the remaining terms are 14 square minus 7 square. So 14 square is 196 and 7 square is 49. So that gives the answer as 147, right? And obviously you see 40 by 360, right? This 0 will cancel and you can cancel 4 and 36 by 9 times. 9 4s are 36, right? So 1 by 9 into pi becomes 22 by 7 into this value. And again 7 and 147 can be cancelled by 21 times. And when you multiply here, we are getting the answer as 462 by 9. So again when you cancel it by 3, here we are getting 154 by 3 centimeter square, because again this is an area, right? And since the radii are given in centimeters, you have to write the area also in centimeter, right? So that's all. If you have any doubt, let me know in the comment section. Thank you.